everyone. I'm Yingfeng and my teammate is Yufan, and I'm here for presenting the results of our final project, TrojanMap. I'm going to work through all these 7 steps, and including the details and some interesting points. So let's do it. The first one is the autocomplete. We are given a partial name and need to return a list of possible locations. The given name can be case insensitive, and we can just transform to lowercase and traverse the odd nodes on the map and to find if it is a possible location. So the time complexity is O of n, and here is our result. And for second step, we need to find the place's coordinates. For example, if we input a location like target, it will return a latitude and a longitude and show the location on the map. The time complexity is O of n. And for step 3, it's a shortest path problem. We need to enter the start and the end location of the path, and it will return the distance of the shortest path and show the path on the map. And we did it by 2 algorithms, Dijkstra and Bellman-ford, and did some comparison. The first comparison is time complexity. For Dijkstra, it is O of E plus V squared because we use a vector. And E is the edges, V is the vertices. And the Bellman-ford, the time complexity is O of E times V. And for runtime, I used the 10 different inputs and calculate the average runtime. For Dijkstra, the runtime is about 1.7 seconds, but for Bellman-ford is almost 21 seconds, which is more than 10 times than Dijkstra. Okay, for step 4, it's a TSP problem, and I want to show our animation. So here, if I want to select 10 random points, and it would show like this. I also did some comparison in these 3 algorithms, brute force, backtracking, and 2 option. For time complexity, the optimal algorithm is 2 option, and which is O of n squared. And for runtime, if we select the many points, like more than 15 points, brute force and backtracking will cost more than 5 minutes to run. But for 2 options, it's very quick. But 2 options sometimes may not get the optimal solution. If we input this and the optimal distance is a little bit smaller than the distance calculated by 2 options. So for step 5 is a cycle detection. We need to enter the bound of a square and to say if there exists a cycle in the subgraph, and show the square on the map. So here is and the time complexity is O of V plus E. And for step 6 is a topological sorting problem, and we use the DFS to implement this. The time complexity is also O of V plus E, and the result is a sorted path with given dependencies. And for step 7, we use priority queue to find out the k closest points and show it on the map. The time complexity is also O of n. So that's all. Thanks for listening, and bye-bye.